All right, folks, we're still in unit one here, and we're gonna begin by going through the first couple chapters of the book. I'm logged into the website version. You can see the URL up in the address bar. And from my understanding, that is completely available for free, so it might negate the need for a lot of people to buy the book. I am also signed in to the website, so it keeps track of where I'm at, what I've read, and gives me access to some features. And it also flips me from dark mode to light mode, which is, maybe better for these videos ultimately. Um, I'm hoping that the Zoom level is okay here for you guys, but I intend on basically rifling through these first two chapters and talking about the key aspects of it. All right. I'm going to do that not by reading you the book, but kind of looking at its content and giving you my spiel on it, if you will. Right. So you take that for what it's worth. Some of the information I noticed because I was rereading it earlier today does repeat from chapter to chapter, but that's mostly for reinforcement. But let's get started. Okay. Um, so this chapter, it says here, what does it cover? And you can see right at the top here that it covers what is .NET Core, what can you build, and how it works. Right. So that's where we start out. Um, well, first of all, what is .NET Core? So we've talked about this a little bit, but ASP itself originally started as we'll call it a scripting language that was a server-side scripting language, very much like PHP, where you would write a command, and then when it would render to the browser, it would convert that code into the HTML output that you would want. And that's where we started in old school ASP websites. And notice how I don't say .NET, just ASP websites would use that ASP scripting language. That scripting language is still around, and there are times where we do incorporate it into ASP.NET websites, right? Pretty rare these days. Web pages that were created with ASP scripts, is what we used to call them, usually have a file extension of .asp, right? Which totally makes sense. .NET Core is not that though. .NET Core is a follow-up to the technology that we used to call the .NET framework, which was the same framework that runs all Windows applications in both a GUI and non-GUI format. And that old framework, the one that they just typically call .NET framework, like you see down here, that's the one that we used to teach in this class. And this is actually my very first iteration of moving away from building apps with that framework in this class. So you guys are the lucky, I don't know, progenitors or whatever of .NET Core here at Gateway. It's not that it's not used, and they make that point in the book all the time that the old .NET framework is no longer being updated. I think they do security patches, but they don't add new features. All the new features go into .NET Core. .NET Core has been around for a while, and okay, so why didn't I switch to it right away in teaching? Well, some of it's just really kind of from a practical standpoint, because I know that most of the places that would hire our students are still using the regular .NET framework in many cases to drive their apps, because that's, they already have stuff built in there, so they're not going to like completely rebuild it from scratch. The author does talk about that as an option though. And real frankly, whenever technology comes out and it's brand new, it doesn't mean that you should be the first one to adopt it. It might be kind of cool. Oh, hey, it's multi-platform. It works great. But my first tries with it, I thought were really disappointing from a multi-platform standpoint. I think it's only recently with the 7 version and the 6 version that it got good enough to really use in production, real frankly. So a lot of the .NET teaching that we get now is .NET Core, and usually libraries version 6 or 7 are pretty typical. So when we think of .NET Core as a technology that we use to build applications and how it works, they have this little diagram here, so I have it up on the screen for you guys to kind of take a look at and how it operates. So whether we have a regular browser client or something that's maybe a little bit more involved, it all ends up going through the framework ultimately to a series of different types of pages, right? So in other words, um, this is the framework that builds it, but these are the things that we typically will interact with, right? And those could be Razor pages or MVC controllers or the APIs that you see listed. And then we'll typically have C# programming code sitting behind those files, regardless of what presentation format we're using, whether it's straight HTML or ASP pages or Razor pages or whatever. We still have C# files attached to all of those, and those will handle the heavy lifting of all the back-end programming, right? Whatever business logic is really kind of a good way to say it. That ultimately connects to our data models and data access layers. So whether that connects to a database or text files or who knows what is a storage mechanism that gives us basically, I'll say persistence of the data after the application, after you step away from it, right? And this is a really common kind of model. And I don't expect you to internalize this right away, or maybe even understand what it means right away. And that's okay. So don't feel like you have to memorize this stuff, because I'm not going to test you on it, by the way. But it's just kind of good information. You'll see lots of diagrams like this as we kind of step forward. All right, so this next section, they say like, well, what kind of stuff can you actually build with it? Well, probably one of the most common types of things to build are regular web applications. That's kind of the focus of this class. And we think of often applications as apps. In some cases, we build those as APIs, which are interfaces for controlling the apps, right? And those are offered in a few different formats. We have these minimal, like simple APIs, probably the most common kind of things to do. Often are the driving engine behind a web page or just a simple mobile app, for example. We can have others that are much more robust and others that use, proprietary server-to-server communications, where the servers are talking to each other on the back end, and it has this gRPC mechanism in the back. One way that we push stuff to the front end, or what the user sees, is through a tool called Razor, which is another language. And I don't want to freak you guys out, but like there's these layers that happen in these technologies, and Razor is its own special, I'll call presentation style language that we use on top of this framework. It's got its own syntax. It has some really cool capabilities, and you'll see like when we start using it why. The other thing that we can do is we can build MVC, and they're specifying here controllers. And MVC, by the way, stands for Model View Controller, and it's the model is kind of the code representation of data. The view is what the user interacts with, the screens or the front end. And then the controller is the programming code that steers the application and directs traffic and makes things happen, right? And so you can actually create just the controllers, right? People have jobs that just do that, which is pretty weird. They have this new technology, though, that's bundled into .NET Core, one that I'm not super familiar with yet, called Blazor, which is a combination of Razor and this kind of like single page sort of like front end dev approach that we sort of use for Angular and React, where we're kind of working with these frameworks that have pre-built components and we just utilize them, right? You want a login box? Oh, here it is. You want a drop down for file import? Well, there it is. It's that kind of tool. So they have the WebAssembly, which allows us to build applications very quickly and easily and beautifully inside the browser. But they also have a backend that allows you to interface with other applications and servers, right? So this is the kind of stuff that you can do with .NET Core. What will we mostly do? We will build plain old web apps using some of these technologies as needed for the tasks we're trying to accomplish. MVC is very typical doing ASP.NET Core. It's not a given, but it's very typical. Using Razor pages is very typical as well. The fact that this is cross-platform and the fact that we can kind of run this just about anywhere really kind of makes this technology even more exciting, right? In the past, the only way that we could normally do this is on top of Windows Server and IIS, which is Internet Information Services, which is Microsoft's web browser software. That is no longer necessary, by the way, although it can still run on it. All right. So they talk here a little bit about why you might choose this as a tool. If you're brand new to ASP.NET, there's no reason to look backwards and learn the old stuff unless you're getting hired at a place that is fixing or upkeeping old stuff, real frankly, right? If you're just entering the game now, you just go with .NET Core because this is the current stable recommended versions. And version 6 and 7 really are those. I don't consider the ones prior to that. Like there was a version 5, right? And I didn't really care for it a lot, and it was a little unstable and whatever. Prior to that, the iterations of this class were using .NET 4, which was the regular .NET framework, by the way, if you're wondering the numbering. All right, so they have a little bullet list here. It says like what other, so like has many selling points compared with other cross-platform web frameworks. So it's modern, high performance, open source. Those are all great. Uses familiar design patterns and paradigms, like MVC is one of them, for example. C# is the default backend language, but notice you can also use VB, or you can use F# if you wish. That's on you, right? Those are both available inside of Visual Studio by default. I would, F# is kind of a specialty language. VB is kind of falling out of favor, but a lot of people who work in Microsoft, environments are very familiar with it, right? And that's where I started with the GUI stuff in Microsoft, was on VB. Probably the biggest selling point to me is the fact that you can build and run on any platform. That is a significant change from the past, and we were just talking about that. All right. There are some kind of caveats to that, though. All right, so running on any platform, how exactly do you do that, right? So I've already been doing research on this because I'm like, well, hey, if I can run on any platform, maybe I can like launch this stuff on Prometheus, and I'm kind of still having this thought, maybe I'll make Prometheus do this work. And then I'm having a thought, well, maybe I'll just spin up a separate web server that just does .NET Core. I might do that too. I have that capability on campus. So I'm still kind of experimenting with that thought. However, when you're coding and you're using Visual Studio, and we did this already, right? So we like built a web app, and then we didn't do anything, right? We just hit a couple of buttons, made a couple selections, and then we were able to launch it into the browser and go, oh, wow, I built that and it really didn't do anything, right? And so it does use a built-in tool, built-in web server. And, there's kind of a lot of products that you code with don't necessarily have that feature, by the way. So like you have to like engineer your environment to allow for that to happen. If you're using a higher end coding tool, it should do that automatically. Right. All right, so let's just kind of keep scrolling forward here. All right. So one thing that they have in this bullet list here, and they say, what is an advantage over the previous .NET framework? It's cross-platform. Performance is much better. The hosting is simpler. There's more regular releases with a shorter release cycle. That's very atypical for Microsoft, by the way. It's open source, modular, et cetera, et cetera. And then it has the option, and I'm going to highlight that one, to package .NET with basically in its own standalone deployment, meaning that I don't need to be on a Windows server to make it run, right? And that's a really big issue, because in the past you'd build these cool web apps and you're like, oh, our server is Linux, I can't run it on here. How much does Windows hosting cost? Oh, it costs twice as much. That was always kind of like, oh, I think I'll switch back to Linux and PHP. That was often a little issue that would happen. The one kind of interesting thing about this, though, is there are different ways to deploy to different platforms. And then I want to talk about this. The one method is you run a regular web server add in the dependencies that are necessary to run .NET Core and support the C# language, the compilers and the debuggers and yada, 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 all that stuff. And then you can run it natively on that Linux web server. Or what you can do is what a lot of modern developers are doing is they basically take that and they containerize it. And a real popular container that they're pointing out here is Docker, right? So that's one of those tools that basically packages up your web application along with the tools that are necessary to run it into one convenient package. And then you just run that whole package. It runs the web server basically that's needed and the application as well. And then you can move that from any system that can support Docker. Fantastic, right? And that's a really common way to deploy apps, both mobile and otherwise, right? So that's a really common approach. Now, they're making a little point here that, pushing stuff to Windows and IIS, it's not really necessarily a waste, but, what I think Microsoft is realizing that they're never going to win the web server game, and they're kind of okay letting Linux be the web server, right? It also allows people who are searching for web hosting, as long as .NET Core is supported, you can then use more inexpensive Linux hosting because it tends to cost a whole lot less than Windows does. All right. Now they talk here about how does this technology basically work. And so they backtrack a little bit, and they start talking about how HTTP works, and that's a protocol that works on the internet over networks. So it's a hypertext transfer protocol, and of course the more secure HTTPS, which is the SSL version of that, or the encrypted version. But basically what this little graphic that we have here shows is how this technology basically works. So if you're a user, you go to a URL, you hit it in your browser, that sends a request to the server. The server receives that request and goes, what page are you looking for? Oh, this one. And then it goes into its file system. It pulls back the HTML and it sends back an HTTP response to the client. And then the client renders it in the browser, the client being the browser software. And then that knows how to take that HTML code or whatever it sends and put it back up on the screen for us to see it. That's how an HTTP request works. And ASP.NET Core sort of works like that, and truth be told, HTTP is powerful, but also has some very significant limitations. Probably the most significant limitation is HTTP is technically what we call a stateless protocol, which means it doesn't maintain its current state of existence. So for example, if I go to a website and I log in, right, it's not going to remember that I'm logged in. I have to write programming code to have it remember that I'm logged in. That's just one example, right? All right, so they do give you a couple of little interesting little sidebars here. So I would suggest that you read these to talk about what is a host name, right? A host name is basically the name of the server that we're connecting to, very often like a .com server. Our Prometheus server is on Gateway's campus is prometheus.gtc.edu. That's actually a subdomain where the host name is really gtc.edu, for example. They also talk a little bit about HTTP and where it came from, and how the information moves about. And this is actually a whole field of study in itself. But this is the mechanism that drives the web, folks. I mean, every time we're connecting to something and pulling information back or sending requests out, there's a format for it. That's what protocols are all about. So it's a standardized rule set for sending information back and forth across the internet. And it's pretty amazing that this technology now is, well, gosh, like pushing on 40 years old, HTTP. It's not the oldest of internet protocols, but it's certainly one of the more powerful ones. And partially we can thank people like Tim Berners-Lee for the development of this technology, by the way. Now, whenever we use HTTP to request stuff, and I'm going to have you like kind of think about this when you're surfing, because most of us don't even think about it, right? Whenever we go to a website, we bring up a page. Rarely these days, and think about this, rarely do we like open up a tab and type in an address. I mean, we do. More often, we'll type in a search, right? And we'll do a search, and then you find a link that looks like the right one, and you just click it. You don't think about what goes into the address bar. But if you do something simple, like even go to Google and search something goofy like, I don't know, football, right? Um, and then take a look at your address bar and what's happening up there. There's a whole lot going on, right? And really what's happening is if you start to break this apart and look at the little pieces of it, information's being transported in what we call key value pairs. And there's like a name for something, and then there's the data that you're looking for, and they travel together as little snippets of information. And then that hits like a database or an application somewhere else, and then data is extracted. So Google doesn't magically like all of a sudden go out to the internet and look up football, right? It has this already stored in a database. So it knows that when I type football and I'm in Wisconsin, I mean, it should bring up Packers, but we brought up NFL. I guess that's okay, right? But if I was in England, would it give me this? Would it give me NFL? Probably not. You know what I mean? So there's some intelligence behind it. There's an application behind it, and it's qualified by who you are as a user, where your location is, and how you're using the technology, and what search criteria you put in. All of that is relevant, right? All of that is transported through HTTP, um, and it kind of shows you the power of it. HTTP is also responsible for transporting all of the pages that you interact with on a website, and all the content and all the files. So, for example, if you're hitting a web page and the web page says, well, hey, I need this JavaScript file, I need these CSS files, I need these images, etc. All of that is handled by HTTP. It handles all of those transmissions. Um, right. And they make a little example here, and I think this is kind of interesting. So why is it you go to some web pages and they're boom, they're up, right? Then you go to other web pages like, Amazon, and at the time the guy wrote the book, Amazon.com makes 410 file requests, including CSS files, JavaScript files, and images. That's insane. Then you wonder why it doesn't load instantaneously. Well, there's why, right? Or if you go to some pages and you look at like the length of maybe even one or two of the JavaScript files, and it might be like 10,000 lines long. Oh my God, it's got to read, it's got to download it all, it's got to read through it all, it's got to run the code, and then put the stuff on the screen. So it's really pretty amazing that any of this stuff actually works. But HTTP is the mechanism responsible for kind of handling all of that. Now, they're going to make a little bit of a difference here as to how ASP.NET Core handles a transmission request versus other technologies. So, for example, when you look at .NET Core, it kind of processes everything through a different layer. The one thing that's kind of interesting is when they re-engineered this product, and instead of having it use IIS as its web server, or the lightweight version, the express version of that same piece of software, they built a brand new web server product that handled .NET Core natively called Castro. And I think I'm saying it correctly, which handles both the requests and the responses. It still transmits over HTTP, but it also handles all the aspects of the application itself and how it interacts with the language. It's part of the reason why it is much faster than some of the older technologies. So .NET Core is known for speed. So that's a really important aspect of it as well. They do walk through a little bit here about some of the technical details about how it kind of works. But generally speaking, that's the technology that drives it. So whenever we hit that like build button where it runs the application in the browser, that's this web server software that's running in the background. Now, what we're going to learn in this book, right? And I think that we're probably going to run out of time here to do much more here tonight, but it talks about these key bullets here. Predominantly, you know, we have all these different things that we're going to learn, but there's some things that we're going to do a whole lot more in the book than others. So how to build HTTP applications, right? Using as small APIs as possible. That's the minimal APIs. We're going to build Razor pages. We are going to work with models and binding and validation and routing. All that is pertinent. We're going to learn how to use Razor syntax and how to use helpers is what we call them. And then how we can inject stuff into applications, how to add logins, you know, HTTPS and all those like other things that make an application truly what it is. But you know, for the most part, we are going to be building apps. You know, that's kind of the main focus of the book. All right, so here's a summary for the chapter. And folks, we are basically out of time, so I do have to cap it here. What I'm going to try to do is record the chapter 2 content separately and publish that in a separate video, so you guys have that as well. There's a little repeat between the 2 chapters, but when we reconvene next week, we will be pushing into chapter 3 and starting to build. All right, so this video ends here.